Hi, in this video we're going to see how we can find the distance between two 3D coordinates. Now I'm going to explain how it's going to work, but I'm then going to give you a formula which you could then just use for the purposes of this question. But imagine that you have 2 points, let's call them point A and point B, and we want to find this distance between the 2 points, so the length of this line here. Now, we saw in previous videos on 3D Pythagoras that what we do is we try to identify a triangle and then use Pythagoras on that. So if I just turn this into a triangle like this, you can see that we've then got a triangle floating in space here, a right angle triangle, and we can use Pythagoras on that. Now, let's consider what the lengths on this cuboid are. If we've got these two coordinates, then this is the x direction. Then this length here, can you see of the cuboid, is going to be the difference between the two x coordinates of A and B. Because the x coordinate of this point here is the same as the x coordinate of this point here, and the same as the x coordinate of this point here. So these 2 points will have the same x coordinate. So therefore, the difference between the x coordinates of A and B will be this length here, the change in the x. So what I'm going to do is I'm going to write on here change in x. That triangle is actually the Greek letter capital delta. That just means the change in. And by similar logic, we can find that this will be the change in the y value here, and this will be the change in the z value between the 2 points. And then what we can do is we can use Pythagoras initially on this right angle triangle here to find out what this length is, this blue length is. And then we can use the yellow triangle with this length here and this length here to find out the length of AB, basically. So let's focus on the purple triangle first. So we've got a change in x at the bottom here and the change in y. So let's make that more of a triangle. And this is the purple triangle we're dealing with here. And we first want to find this blue length here. Let's just call it k for the moment. So I'm just going to call it k. Then by Pythagoras theorem, k is the square root of the change in x squared plus the change in y squared. I sort of skipped a few steps here just to keep this video more brief. And that means, therefore, we've got this length here. This here is the square root of change in x squared plus the change in y squared. And now we can look at the yellow triangle. So if we draw the yellow triangle, let's highlight it in yellow. What lengths have we got on here? Well, we've got this change in x here, change in z. And at the bottom, we've got this length we worked out, which is the square root of the change in x squared plus the change in y squared. Now, if we use Pythagoras theorem on this, and by the way, this length we're trying to find, the distance between A and B, we're going to call D. Then using Pythagoras theorem, if we label the two shorter edges as A and B in either order, and then the hypotenuse as C, by Pythagoras theorem, A squared plus B squared is equal to C squared. Now, A squared is just, in fact, let's label these the other way around, sorry. You'll see why. So I'm going to make this A and this B. Then A squared is going to be this whole thing squared. Now, the squaring it gets rid of the square root. So you're just left with the change in x squared plus the change in y squared. And we're adding B squared, but B is the change in z. So it's the change in z squared. And that is equal to the distance squared, the c squared, so the distance squared. And now we can square root both sides. So d is therefore the square root of the change in x squared plus the change in y squared plus the change in z squared. And if you remember the videos we did on the distance between two 2D coordinates, remember this formula was identical except for we didn't have this change in z. So it was just a square root of change in x squared plus a change in y squared. So that is the formula that we need to use on this problem here. And we've got these 3 coordinates here. So we've got P is, well, 2 coordinates, sorry, 2 3D coordinates. P is 0, 2, 1, and Q is -1, -3, and 9. Now let's work out what the change in x, the change in y, and the change in z is. Now the change in x is what we're getting from to go from 0 to -1. So the change in x is equal to -1. The change in y is what we need to get from this y value to this y value. So you can see it's going down by 5. And the change in z is the change from the 1 to the 9, which is going up by 8. So there we go, that's a change in z. And now we can use our formula above, the one highlighted in purple. So the distance between these 2 points is going to be the square root of the change in x squared, so the -1 squared. Now I'm just going to ignore the negative symbols because when you square a negative number, it becomes positive anyway. So we're going to get 1 squared plus a change in y squared, so -5 squared, which is just the same as 5 squared, plus a change in z squared, so 8 squared. And then if I just do that on my calculator, that's 1 plus 25 plus 64. And that's going to be 26 plus 64 is 90. So it's root 90. And it wants it to 1 decimal place. So square root of 90 as a decimal is 9 point, to 1 decimal place, 9.5. So the answer is it's 9.5 units to 1 decimal place.